Hello, welcome to my mini tutorial on building and designing rockets in Kerbal Space Program demo. First thing you need to know is that when you get into the vehicle assembly building, the first thing that you place is the command pod, and everything has to attach to the command pod or to something that is itself attached to the command pod. You just click the thing in the list of parts, and then you click again when you have snapped to the thing that you want to connect to. If you try and place something that's not connected, it will show the sort of little red ghosted sort of thing, and you won't be able to connect any parts to it. Nothing will snap to it. So that's important to know. The controls for placing things at different angles are the W, A, S, D, and Q and E will rotate things clockwise and counterclockwise. Is this more able to be easily seen from the top. However, if you have a part that's kind of symmetrical, it's kind of hard to show that, so I'll pick one that's not symmetrical. There you go. And another thing that you will want to be aware of is the fact that when you're designing, you're most likely going to want a small engine for your upper stage, and you are going to want a bigger engine for your lower stages, or multiple engines. So the other controls that you need to be aware of are the staging controls. If you've placed a bunch of items, it's most likely that you're going to want to hit reset every once in a while to realign all the things that are staging differently to make sure that things are actually firing in a sort of reasonable way. However, sometimes you want to manually override the order things are firing in, and when you do that, then you basically are just clicking and dragging from one set to the other. And I will show you that shortly as I build a craft that actually is somewhat more worthwhile actually demonstrating this on. So I'm going to have a upper stage, a middle stage, and an outer bottom stage. That's the upper stage right there. There's a stack separator in between. Then there's the middle stage, and attached to it I'm going to have some radial decouplers, which are going to allow me to stick more rocket engines to the side. And I'm going to hit the X key, which is a shortcut for the symmetry mode, which is actually this little icon down here. There's also the angle snap. The shortcut for that is C. I almost never turn angle snap off. Basically, angle snap will make it so that it will jump between little sections like this, whereas if you turn it off, you can have a smooth sort of path that you can select to place anywhere. But angle snap is usually much more useful, especially when you're placing other things and you want the other things to line up. So I'm going to place 3 radial decouplers, and I'm going to place some tanks on those decouplers. And you'll actually notice that I'm trying to make these tanks sort of line up with the other tank, but I'm going to want to make it so that they're slightly lower perhaps, if anything, not slightly higher. Because what's going to happen is I'm going to want to use this for having all my rocket engines be pretty much level on the ground. And it looks like I put it slightly too high. Oh. Sometimes you'll see a bug in the game where it stops snapping to parts. You'll also want to be certain that you are pointing at the middle of the part that you want it to try and snap to, because if you do not, often what will happen is it'll snap to it, but it'll kind of be at some sort of weird angle when it does so. And this part is doing it again, so I'm going to toss it and pick a different one. Even though it's the same fuel tank, I'm picking a new instance of a fuel tank, and sometimes that makes the problem go away. It can be difficult to get everything all lined up exactly the way you want it, so you often will find yourself trying again. You can hold shift and use the mouse scroll wheel to be zooming in or out. That usually helps with the placement of parts. And I think it goes right about there. That's close enough. I think it's not clearly above, so that's good. When you don't hold shift and you use the scroll wheel up and down, then you will be able to move up and down vertically to scan the top or bottom of your ship. And of course, when you're holding shift, then you go zoom in and zoom out, as I previously said. That's very useful to know. Often what you'll find yourself doing, especially when you're trying to get into some really tight space, is you might actually have to scroll way in. Another thing that might also be useful is sometimes you'll find that you actually want to get into a place that it won't let you get into. So what you can do is you can actually click on the command pod to move the whole thing a little bit to the side. Then when you turn to that side, you'll actually be closer than you normally would be able to get to it. So now I can get extremely close in there on that one side, and I can get even closer if I move it a little more to the side. Now when I go over here, I actually should be able to go inside. Yeah, see, now I can see inside of the tank, and I'm actually seeing the connector right there. So that's useful sometimes if you're going to place fuel lines and you want to make sure they line up correctly, but I don't actually need that. So, but I am going to need some fuel lines, so I'm going to place fuel lines, and I'm going to use the radial decoupler as a sort of indicator to make sure I'm lined up correctly. There we go. And doesn't actually matter because symmetry isn't entirely important for parts that aren't rockets themselves. The aerodynamics are not that finicky in the game. In fact, you'll actually even find that you don't even need to use things like nose cones, although it is sometimes nice to have just for aesthetics, because in this game it doesn't actually really accurately model the aerodynamics. If you weren't to put those nose cones on in real life, what would probably happen is your craft would be burning a lot more fuel than if you did put them on. So as you can see now, the reason that I tried to line these tanks up exactly as I could was so now the very bottoms of the rocket engines will line up. If you get them to line up quite perfectly, then you will not need to use any sort of structural thing like these stability enhancers. You won't need to place them in order to have your craft be able to take off safely. You actually would be able to just have the craft sitting on a launch pad without any sort of stability enhancer. If you do use them, however, one thing that you'll want to notice about them is that when it places them, it puts them in a different group here, a different staging group, and you're probably not going to want that, because what happens is if you press space, which is your staging key to fire the next stage, the little clamps on there will let go, and then your spaceship will just fall into the launch pad and most likely blow up. So when I hit the reset, you'll actually see that it put these 3 engines to fire at the same time. So basically what will happen is, assuming that I've throttled up, then when I press the spacebar to stage, the rocket engines will kick in at the same time as the docking clamps let go. Now I want to actually change something to non-standard, non-default, according to what it thinks that I should have it set up as. So I'm having the 4th rocket, the one in the center, actually fire at the same time. And now these fuel lines are lined up. Basically when you place a fuel line, you're going to want to place it such that you click first on the place that you want to direct fuel from, and then you click again to place it on where you want to divert fuel to. You can double up your fuel lines. You can have one starting from the outside and one going to starting on the outside and going to the inside, and you can have one that starts on the inside and goes to the outside, and that would actually ensure that you have an even distribution of fuel in all the engines. But I actually don't want that. I specifically don't want that. I actually want the fuel to empty from the external ones before drawing from the internal one. So I place the fuel lines first on the outer and then connecting to the inner afterwards. So what that will do is when I actually burn through the fuel in these outer tanks, I can blow these clamps, these radial decouplers, and the outside engines will fly off and the craft will continue upward. Another thing to watch out for is that sometimes if you're in the middle of a turn when you fire your decouplers, the inside part of the rocket actually might be spinning around a bit, and you might end up hitting the newly ejected decoupled outside section, so you want to be careful of that. Another thing that you're going to want to do is you're going to want to make sure that you have some RCS fuel on your craft, because if you don't, it's going to be kind of difficult for you to do any sort of steering when you're actually out in space. And of course another thing you're going to obviously want is you're going to want a stack decoupler at the very top above all this, because when you're returning to the planet, you're probably not going to want to take all this junk with you, because your parachutes will be slowed down because they'll have to be dragging more weight. And that reminds me, you're going to want to put a parachute on top. In the full version of the game, there's all sorts of different parachutes, like radial setup parachutes, where basically you can have parachutes that are on the side of the craft, and you can have one on the top as well. Another thing that you're going to want is the RCS fuel is quite useless if you don't have any thruster blocks, so I'm going to put some thrusters on. Now the good thing about RCS is that you don't actually have to have the thrusters connected directly to the RCS fuel tank. it magically puts the lines in through whatever you want. And what you're actually most likely going to want to do when you plan where to put your RCS thrusters is you're going to want to put them near the center of mass, in fact. The benefit of that is that when you are wanting to spin when you're in space to turn yourself, you'll be spinning on an axis which pretty much lines up with the center of mass, so you're not going to be too surprised with the direction that you do spinning in. That's very useful for if you're doing any sort of docking maneuvers to try and dock with another craft that's on a very similar orbital trajectory. However, there's not actually docking in this game because there are not docking ports in the demo version, but in the full version there most definitely is docking, and you can do all sorts of cool stuff like you can attach satellites, or you can have a fueling depot so that you go out into space and you refuel once you're in orbit and then go off for a further interplanetary mission or whatever. You want to make sure that you have landing gear on your upper stage if you're planning to do any sort of landing anywhere. If you forget that, you're going to have a bad time because your engines are most likely not going to want to take the brunt of the landing that you're going to be doing. If you look in the statistics, when you mouse over the actual landing struts, it says impact tolerance is 12, that's 12 meters a second, whereas the engines, most of them are most likely impact tolerance of about 6 or 7 meters a second, which means that you're going to break them off if you land even at a pretty slow speed, whereas the landing gear give you a little more leeway with that. Now there's this one RCS fuel tank. I could also put these radial ones on, but I don't really feel like doing that, so I put the inline one in. The difference is that some of them have different fuel than others, so you might prefer one over the other based on just how much fuel you want in the different stages. Another thing that's important to know is you want to make sure that your thrust to weight ratio is sufficient so that on all stages of your craft, you're actually going to be able to continue rising through the atmosphere. If your thrust to weight ratio is less than 1, then you will not have enough thrust to actually move upward, and you'll just crash back to the surface. There's no actual indicator that tells you anywhere that your thrust to weight ratio is sufficient, but you can figure it out from trial and error, or you can figure it out from installing some sort of add-on such as MechJeb, which is a sort of kind of combination of an autopilot and a sort of statistics gathering thing that will indicate a whole bunch of useful statistics to you. So this craft looks pretty much like it's ready to launch. I'm just going to make sure all the staging is correct, and look, actually if you see it's not, I hit reset again, which means I am going to have to bring that middle engine down into the bottom staging group. So on the bottom stage I have the clamps, I have the 3 engines, I have the 1 center engine, then that's that stage. So when I fire, all those things will activate at once. In the 4th stage, what happens there is the radial decouplers will separate and the outer engines will fly off. In the 3rd stage, the other inline decoupler here will fire, and I will be down to just my upper stage at that point, and up here the engine that's just above it will take over. What I like to do often is combine the engine that is going to take over right with the same stage as the decoupler that sets it free, because that way I don't have to have any sort of time delay in between separating my stages and having my next engine kick in. I can have the engine kick in immediately, so I don't lose any velocity or waste any time. Then the next stage, the stage 1 that I have here, is the top decoupler breaks off and just the little landing capsule comes apart, and the capsule and the parachute are all that remain at that point. And the 0 stage is just firing the parachute, and then that would bring me safely down in the atmosphere if we've done everything correctly. So this craft is now complete, and we here have a craft that actually would be pretty much ready for taking you to the moon. The one thing, however, that you might want to not forget is there's struts here in the structural tab, and what you're going to want to use them for is to brace things that may not be all that stable. If we didn't brace this, then the only thing connecting the outer rockets to the inner rockets was these decouplers, and so most likely what would happen is that the engines would be torquing in all sorts of strange directions, especially if I did any sort of turning, and I would most likely tear my craft apart, and I probably don't want to do that. I probably want to actually get somewhere rather than having it torn apart. So I'm going to put some struts on this thing. The good thing about struts is that if you are staging, the struts will automatically separate themselves so they won't hold the craft together. And you can pretty much place struts just about anywhere that you might imagine that you would want to possibly place them. It's better safe than sorry with struts normally. Sometimes you don't need that many of them, but you can make just about any crazy design work as long as you have enough struts and as long as your your center of mass and your center of thrust are pretty much aligned. If they're not aligned, then you're going to be torquing all over in some strange direction, but in most simpler craft, it's very unlikely that you're going to have any sort of inequality that's going to cause you to torque in some direction, especially if you use the symmetry mode when placing items. There's also this center of lift indicator, but that's not really used because we are not building any sort of space plane in this demo. So this is our initial sort of beginner craft that, if you pilot it correctly, would take you to the moon. So I'm going to save this and I'm going to make it available online along with this video. So thanks for watching. See you out there.